Now, let's move to solve an application. We will solve Toolbook Exercises. The first exercise is exercise 18, page 104. Consider the circuit represented in figure 16. The dry cell maintains a constant voltage UPN equals 9 volts. R1 equals 100 ohms and R2 equals 200 ohms. Part A. Find the resistance of the resistor equivalent to the two resistors. The two resistors are connected in series, then R equivalent is equal to R1 plus R2 equals 100 plus 200 ohms equals to 300 ohms. This figure shows the equivalent resistor for the grouping. Now part B. Calculate the current sent by the dry cell. To calculate the current I sent by the dry cell, apply Ohm's law on the equivalent resistor of resistance Re. UPN equals Re times I, then I equals UPN over Re equals to 9 volts over 300 ohms. This will be equal to 0.03 amperes. Now, part C. Calculate the voltage U1 and U2 across R1 and R2 respectively. Verify the law of addition of voltages. The two resistors are grouped in series with the dry cell. Then the current I sent by the dry cell traverses the two resistors of resistance R1 and R2 respectively. Then I equals I1 equals I2 equals 0.03 amperes. This is the law of uniqueness of current in series grouping. To calculate U1 and U2, we will apply Ohm's law on R1 and R2 respectively. Then U1 equals R1 I1 equals 100 ohms times 0.03 amperes equals 3 volts. While when applying Ohm's law on R2, U2 equals R2 times I2 equals 200 ohms times 0.03 amperes equals 6 volts. Now, let's verify the law of addition of voltages. Here we have U1 across R1 equals 3 volts, U2 across R2 equals 6 volts, and UPN equals 9 volts. Let's compare them. If we add U1 plus U2, we will get 3 volts plus 6 volts equals to 9 volts. And the dry cell maintains a constant voltage of 9 volts. This is given. Then the addition of U1 and U2 is equal to UPN, so the law of addition is verified. Now let's move to solve exercise 19. Consider the circuit of figure 17, where R1 equals 40 ohms, R2 equals 10 ohms. The generator sends a current of 1 ampere. Part A. Calculate the resistance of the resistor equivalent to R1 and R2. Here we have the two resistors are grouped in parallel. Then the resistance of the resistor equivalent to the two resistors can be calculated according to the formula 1 over R equivalent equals 1 over R1 plus 1 over R2 equals to 1 over 40 plus 1 over 10 equals to 5 over 40. Then R equivalent is equal to 40 over 5 equals to 8 ohms. This figure shows the equivalent resistor of the grouping. Part B. Calculate the voltage U across the generator. To calculate the voltage U across the generator, we will apply Ohm's law on the equivalent resistor of resistance Re. So U equals Re times I, 8 ohms times 1 ampere. This was calculated in part A, and 1 ampere is given, so it is equal to 8 volts. Now part C. Calculate the currents carried by R1 and R2. Verify the law of addition of currents. The two resistors are grouped in parallel with the dry cell, and the voltage U across the dry cell is equivalent to the voltages U1 and U2 across R1 and R2. Then U equals U1 equals U2 equals 8 volts. This is the law of uniqueness of voltages in parallel grouping. To calculate I1 and I2, apply Ohm's law on R1 and R2. So U1 equals R1 times I1, then I1 equals U1 over R1 equals 8 volts over 40 ohms equals 0.2 amperes. Similarly, for the second resistors, I2 will be equal to 8 volts over 10 ohms equals 0.8 amperes. Now let's verify the law of addition of currents. Here we have I1 carried by R1 equals 0.2 amperes, and the current carried by R2 equals 0.8 amperes, and the main current is 1 ampere. Then, if we add I1 plus I2, it will be equal to 0.2 plus 0.8, it will be equal to 1 ampere, but the main current I is equal to 1 ampere, and this is given. Then the sum of the two currents will be equal to the main current. Then the law of addition of current in parallel grouping is verified.